Okay, now suppose you want to describe how the temperature in one part of the room varies with respect to another part of the room. Now the temperature is going to depend on three variables. It's going to depend on X, Y, and Z. And how the temperature varies is going to depend on what direction we take. So in order to describe the temperature variation between 2 points, what we must do is take the partial derivative of the temperature with respect to X, with respect to Y, and with respect to Z. So here we have the theorem for partial derivatives, which states that dt is equal to the derivative of t with respect to x dx plus the derivative of t with respect to y dy plus the derivative of t with respect to z dz. Now this is can in fact be written as a dot product where we have dt is equal to the derivative of dt with respect to x hat plus the derivative of t with respect to y hat plus the derivative of t with respect to z hat. And I take the dot product with the x hat plus dy y hat plus dz hat. So what in fact we have here is we have the gradient, which is given by this first term, and we're taking the dot product with, and we've seen this bit before. We saw this in the first lecture. This is our infinitesimal displacement vector, dl. Okay, now if you recall, of course we have x hat dot x hat, we're going to be left with 1. Y hat dot y hat is going to be equal to 1. But we have x hat dot y hat, it's going to be equal to 0. So what we see is that the gradient of t is going to be equal to dt over x hat plus dt dy y hat plus dt over dz hat. Okay, so the gradient is a vector. It has both direction and it has magnitude. Now let's do an example. Let's say we want to find the gradient of the following function. There's a function that depends on x, y, and z, and it's equal to x squared, y cubed, z to the power 4. So let's take the gradient of this, of f, what's this going to be equal to? Okay, so just let's think for a minute. Well, what we must do is, in the first instance, we take the derivative with respect to x. Okay, so what we get is 2x y to the power of 3 z to the power of 4 x hat. Next, we take the derivative with respect to y. So we're going to have 3x squared y squared z to the power of 4 y hat. And then thirdly, we take the derivative with respect to z. So it's plus 4x squared y cubed z cubed said hat.